Hello, I'm Don Morris from H&R Trains, and we're here at beautiful Cypress Gardens in Winter Haven, Florida. I recently had the pleasure of working with Paul Bussey and his very talented crew from Applied Imagination while building this railroad, which consists of 537 feet of stainless steel track. This kit-bashed Bachmann trolley, along with the Aristocraft passenger train you see here, are just part of the trains operating on this extremely large layout at Cypress Gardens. The buildings and bridges on this layout are all made of natural materials. The buildings are patterned after famous Florida landmarks. Many of the same techniques that were used to build this railroad we'll be using throughout this video. Look what's growing in the garden. An important part of garden railroading is the planning. Computers can help to make that easier, so let's get started. You'll need a basic site plan to mark the location of fixed objects such as trees and other shrubbery, the walls where the train is going to run behind, ponds and waterfalls, and the walkways. Use a tape measure to mark the location of anything that might impact the railroad as you go along. Also mark the elevation of prominent points on the site, and we'll demonstrate how to do that later in this video. A simple sketch will do, but we did ours on a computer. The outside loop on this railroad has two passing tracks, one at the top and one at the bottom, and a spur. The inside loop goes around the lake and the waterfall, and it has one passing track. We also have a cog railway, which is a point-to-point railroad. One of the things we want to consider when we're building our railroad is the minimum radius. It's important that the radius we use is big enough so that the equipment we have to run on it will run smoothly, and it'll also look good. It's best to use the largest radius that'll fit in the space that we have available. We're going to use a 4-foot radius as our smallest radius on the railroad. We'll use a lot larger in most places. Let's talk for a minute about the different types of track that are available. Several alloys and several different styles of track are available, but nickel silver, stainless steel, aluminum, and brass seem to be the norm. Flex track as well as sectional track are available. We're going to use a combination of sectional track and flex track on our railroad, and we're going to use 3 different types. We're going to use Aristocraft, LGB, and stainless steel track. We're going to use the Aristocraft track on the passing track and the spur in the front of our railroad. This track is a brass alloy, and it's attached with a stainless steel screw at each rail joint to hold it together. The LGB track we're going to use on the rack railroad, it's also a brass alloy, and it has a small area on the end of the track where a clip goes between the ties to hold it together. The rest of our railroad we're going to use stainless steel track, and primarily we're going to use flex track where we bend the track ourselves. It has a rail joiner which has a wedge built into it to give you good electrical continuity. There's also a slot that allows for water drainage, and there's a clip underneath if you want to use a clip between the pieces to hold them together. This track offers a lot more possibilities for lower maintenance. It's not necessary to clean quite as often as the brass. All 3 are really good products. In addition to using large radiuses on a railroad, it's a good idea to use transition curves wherever possible. A transition curve is one that allows the track to transition from the straight into a curve by gradually increasing the radius to its sharpest and then coming back gradually to a shallow radius and then back to straight again, rather than having it all of a sudden hit that sharp curve. Let me draw what I'm talking about to show you. If we start straight like this and then all of a sudden have a sharp curve, there's going to be a lot of wheel wear in this curve. But if we have a straight section and then gradually come into the curve like this, it's going to be a lot easier on the train, a lot less wheel wear, and it'll just run a lot smoother.
One problem I see quite frequently on garden railroads is derailments that are caused by reverse curves. And that's something we want to try to avoid. Let me draw this out so you can see what I'm talking about. If we have a curve which comes one direction and then immediately comes the other direction, we tend to have a lot of derailments right in this area. The best way to handle that is to start our curve and then put a straight section of track in before we come the other direction that's at least equal to the longest car that we're going to use on our railroad. That'll pretty much totally eliminate any derailments because of that. Another thing we want to consider is the track spacing. The spacing can be closer on the straightaway than it is on a curve. We want to make sure that we have enough spacing so that the cars don't touch each other as they pass. Let me kind of diagram that out here for you. If we have two parallel tracks, they can be fairly close here, up to 6 1/4 inches on the straightaway. And where we have the curves, we want to have them a little bit further apart, more in the neighborhood of 7 1/2 inches. Let's talk for a minute about the grade. By grade, I mean the angle that a locomotive can climb uphill. Long trains don't climb hills very well, so we want to keep the grades pretty much to a minimum. And on our garden railroad, we're going to use 2%. 2% grade will allow us to have some cars running even in inclement weather and fairly long trains. 2%, let me draw this out so you can see what a 2% grade really is. A 2% grade means that if we start at ground level and we come uphill, that starting here at 0 with 100 inches of forward travel, we go up 2 inches. If this was in feet, then that would mean in order for a train to be able to cross over itself at 50 feet, we would be going forward 50 feet to go up 1 foot, or up 2 feet in 100 feet. The roadbed we lay our track on is really pretty important. Unfortunately, we all live in different parts of the country and we all have our own peculiarities to that region. But I've made some drawings here to show you some of the options, and then we'll talk about how we're going to do it. All right, one of the problems we have up north in the cold regions is the heaving in the soil because of the frost level. And so we want to start out by digging a trough and then having crushed stone at the bottom, pouring a level of concrete that has some pressure-treated lumber embedded in it. And that lumber gives us something to screw our track down to. We also have a culvert here for some drainage to go through so that water can go from one side of the track to the other. Now this will work pretty good, but it's really kind of extreme for our climate here in Florida. The next would be to dig the same type of a trough we had before, except this time to fill it with crushed rock. And we lay the track right directly on that crushed rock. It can be anywhere from 6 to 8 inches deep, depending on how deep the frost level goes in your area. And I would make it probably anywhere from 9 to 12 inches wide. The third way is really quite popular, and I see that quite often when I go up into Ohio and in the Midwest. You start by taking pressure-treated 4x4 lumber and digging a hole and maybe pouring some concrete. And to the side of that you put some stringers of pressure-treated lumber, and then on top some more pressure-treated, and then on top of that the track. Once you've done that, then you can backfill the earth so that you don't have the problem with the frost like you would have if it were built right on the ground level itself. There's two other methods I'd like to talk about. One of which is probably the most popular way that I see everywhere I go, and that is to lay the track right directly on the ground. That works pretty good for a temporary railroad, but here in Florida, where our soil is so unstable and sandy, after a period of months it tends to become very uneven, and it requires quite a bit of maintenance. The next way is the way we're going to do, and that's to use pressure-treated 2x6 lumber. You can take the pressure-treated 2x6 lumber, and by butting it together and putting a piece about 12 inches long underneath, and then a pattern of 5 screws on either side of the joint, or 10 screws really, it gives you a very solid base to lay your track on. And once it's all put together, it's one solid unitized floating platform, so to speak, for the track, and it tends to move around with the surface real well. The last thing we're going to consider before we go outside and actually build our railroad is the electrical. Here you see the schematic with all 3 lines, our cog line, the inside loop, and the outside loop. Each one of these lines is going to be fed by its own circuit and its own transformer. We'll talk more about the electrical as we go along while we're building.
Now that our planning's finished, we're ready to start having some fun building our railroad. We've removed most of the plants that are going to be in the way during construction and replanted them in pots or in the ground here in front of us. And now we've gone to the lumber yard and we've gotten some pressure-treated 2x6 lumber, which is here on the car, and we're going to start construction.
First thing we need to do is determine the grade. We've driven a railroad spike into the tie here as our benchmark. We must pick a permanent point for the benchmark from which the entire layout can be seen.
What we've done here is we've substituted an expensive transit with an inexpensive piece of lumber, and we have a sight gauge here, and we have the tool that we can measure the height of the grade. And the sight board is exactly the same height as our 0 point on the board, and we sight through this, resting it on top of our board, and you'll notice that it's exactly the same height as the 0 mark on our board. So we can stand anywhere on the layout with this ruler, and from our benchmark we can determine what the grade is above 0.
This is what we see when we look through our sight gauge. What we do is tilt the sight gauge forward or back until the bubble is centered, and then sight on the line to our ruler, which is in the background.
If we have a part of our layout that's higher than what the benchmark is, then it's going to come up like this and show a plus in the numbers. If it were an area on the layout that was lower, we're going to see a number which is a minus. Each one of these lines is 3 inches apart, so that gives us a pretty good idea of what we can expect on our layout.
We take our improvised transit and we set it on the benchmark. We sight through the sight gauge, and we look at the ruler and take our reading, and then we move it to another point about 100 inches away and take another reading so we can check our grade.
And we need to do this all around the layout.
Okay.
An alternate method would be to pound a couple of stakes on the opposite sides of the area you're working and stretch a string between the stakes, and we'll use a line level. Now, a line level is nothing more than a small level that hangs in the middle of the string where it's going to be fairly level. We level the string, and then we can take some measurements along the string to find out what the grade is. Remember, the reason we're doing this, of course, is because we want our trains to run smoothly. We don't want them to have to run up too steep of a hill. Now we'll make our track roadbed from pressure-treated 2x6 lumber. The lumber we're going to use is going to be cut to length depending on the size track we're using. In the case of a piece of radius 3 or 1600 radius LGB track, we use an 11 1/4 degree angle on the end of the board, the same length as the track. In between each board, we use a 1-foot piece that we use to put the two pieces of wood together. We use 5 screws on either side of the joint to make a good solid joint. Before we put the screws in, we want to use clamps to clamp the wood together so we get a good tight fit. Sometimes when you put the screws in, it tends to push the wood apart. This keeps it nice and tight. The screws we're using, by the way, are stainless steel deck screws. You could use galvanized screws, but they do tend to rust over a period of time. You want to drive the screws in so they go just below the surface. The 5 screws, the pattern that they make really helps to add a lot of strength to this. In fact, when we put the wood together, if we use pieces that are longer than 10 feet, we cut them into 5-foot lengths and then use a joint just to give it a little bit more rigidity.
Now wait a second here. You need to go. Keep it the same place because he's moving. So you have to move the camera. Wait down.
Putting a road bed together like this in small pieces really makes it easier. You can build them in sections and then lay them in place and fasten them into the rest of the layout. It's a good idea that the pressure-treated lumber is used with the grain going the same way on all of the pieces throughout the entire layout. That is to say that the crown of the lumber is all facing up or facing down, and that way it helps to keep the warpage to a minimum. Each section is then attached to the preceding section as we build the layout. We make adjustments, of course, for the different lengths of track, and then screw them together. And I mentioned earlier, we can put several sections together like you see here and then put them in place. It's much easier to do it that way than to do it on the ground. You also have to make adjustments as you go along for plants or shrubbery or other things that might be in the way. Even though our site plan had all those things marked, it's awfully hard to plan everything right down to the last detail. And of course, as things will happen, we have interruptions with dirt arriving on the site. We're going to need that in a little bit to backfill around the roadbed. Want to take some more measurements of our roadbed to make sure the grade is proper before we backfill. So now we're going to check the grade to make sure it's less than a 2% incline, and we do that about every 100 inches. And we'll measure off 100 inches here and then take another reading and see what we have.
Let me have this. All right, +9.
And it looks like we have a little problem, so we're going to have to raise the track up about 6 inches here to give us 2%.
Come over here, I got to explain.
He's cool.
Okay. Just pick them up.
Now we can put blocks under it here or bricks under it temporarily until we backfill it, and then we'll take those out later on.
All right, let's get it. I'm sorry, get it into the center. All right.
That should work pretty good. Right on the money, 6 inches. Now we'll check our grade before we do our final backfilling with dirt around our roadbed. Here we're setting stakes every 100 inches around our roadbed. We could set them more often, but it's just a little bit easier if you use an even number like 100. That way our 2% comes out to 2 inches in 100 inches. After setting the stakes every 100 inches apart, we'll now check one more time to make sure our grade is correct. Incidentally, you'll notice we've stabilized the passing tracks with 2x6s underneath. We've marked the actual grade right on the roadbed, so if we have to make any final adjustments, that'll make it much easier.
I think we've got most of the adjustments done, so we're just about ready to do some backfilling, but we want to check this one more time here and stabilize it a little bit with some wedges. We've marked right on the stake here so we can get a pretty good idea how close we've come. I think it's going to be pretty close. Yeah, it's right on, so we're ready for some dirt. Alright, we're going to put this dirt all the way along the roadbed
Around it.
and then kind of pack it in on both sides. Over time, this is going to settle in quite a bit, so we're going to have to do this maybe a couple of times to get it nice and tight. And then we're going to wash it in with water. Now the water's going to pack it in pretty good underneath, and we'll have to let that sit a while before it stabilizes. It may require some more dirt later on.
While the dirt's settling in, let's do some rock work. First thing we want to do is put water in our wheelbarrow,
And then we add the mortar mix to it. Also want to add a little bit of Portland cement to help hold it together. We mix it all together, and then after we get it pretty well mixed, we want to let that sit a few minutes. And while we're doing that, we can get the wall wet and add some water to the rocks. Let's get some pieces fitted up here before we put any mud on them. And now we're ready to get started. What you want to do is you want to put mud on them and then kind of pack them in place and tap them with a hammer to set them in place. That'll drive some of the mortar out from behind, but it'll also help to seat it pretty good. Now you could hold these rocks in place with little wooden pegs, or hold them with your hand for a little bit and they'll stay pretty good. Just pack it in good around the rock and we'll let that dry. You want to let it sit between 30 and 60 minutes to allow the mortar to set up a little bit, and then we want to scrape off any of the loose mortar that's on the surface of the rock and around the joints. You can actually sculpt the joints a little bit with a spoon or something else. Looks pretty good after it's had a chance to set up. We're going to use flex track on our railroad, so we want to take some of the pieces and lay them down on the roadbed to get an idea how they're going to fit, and then we'll mark where the curve starts and where it finishes, so we'll have some idea where to start bending it. Now we're using 10-foot lengths of flex track, and although this is called flex track, you really need to bend it with a bender that's specially fitted for the rail itself. Alright, need to make an adjustment with a bender, insert the rail, and start rolling the track through to bend it. Now this is all an educated guess because each rail bends a little bit differently. Want to take it back and put it down and see how the bend comes out. Looks like it's just about right.
now we're going to bend another rail parallel to the one we just bent.
These rails need to be parallel, and you need to understand that the inside radius is going to be smaller than the one we just bent. Also, the rails are not the same. When you bend them, it's an educated guess that you're going to get the bend just right. If you make a mistake, you can unbend it and bend it again. We want these rails to be fairly parallel so that when we slide them into the ties, they'll slide in nice and smoothly without any stress against each other. Also, we want to put the open end of the ties to the outside of the radius. Now these look pretty good. They're ready to feed right now. Now as you feed the ties on, you notice the inside rail gets a little bit longer. Not to worry about that. After we put the rail joiners on, we'll cut that off.
Now the rail joiners are really the most important part of our railroad.
Without the rail joiners, the railroad's not going to run. So we want to make sure that we have good continuity at every joint. We're going to use an electrical conductive grease on the rail joiner before we insert it on the rail. And we're going to tap it onto the rail so we have a very good connection. Now these rail joiners for the stainless steel have a little wedge built into them, so they push up against the bottom of the rail and give you very good continuity. A little bit more grease on the other rail joiner, and then we're going to put them together. Now after you put these together, you're going to notice the grease squeezes out, and that's good. It keeps moisture and everything out of the joints. This is very important on brass track, not quite as important on the stainless steel. After we push them together, we're going to want to wash off, or not wash off, but wipe off the excess grease so it doesn't get all over the wheels of the train. Next, we want to align the track with the roadbed and begin anchoring the ties without overdriving the screws as we go. The correct way is to drive the screw down till it just comes to the top of the tie and no further. If you drive it any further than that, what happens is that it pulls the tie down and pulls the rails together, making the rails out of gauge. That's not good. And we need to replace that tie. So just down until it just comes to the top and no more. May have to make some adjustments as we go along here to align the track. And then at the end, I mentioned earlier, we're going to have to cut off one of the rails to get it square with the end and put another rail joiner on. Anytime we bend the flex track, that's going to be necessary. We want to file off any burrs on the end before we put the rail joiner on. And we go through the same procedure, using grease again for the rail joiner. Incidentally, if you're going to use brass track, you may have to drill some small holes on either side of the joint and solder a wire around the joint for good continuity. Also, another technique is to use rail clamps. We want to continue to join the track as we did before and add a power feed track about every 20 to 30 feet as we go. The bottom of the power feed track has a stainless steel strap that's welded to the bottom of the rails, and the wires come out the end of the ties using stainless steel screws. While we're on the subject of electrical pickup, we've decided to put our electrical harnesses in conduit. We're going to feed our railroad from 2 points. The first point is going to come from inside the building and go out to the midpoint of the layout. It'll go underneath the tracks here and come up just the other side of the inside and outside loops. The second section is going to start where the first one terminated and go out to the other side of the layout, indicated by the arrow here. Next, we're going to pull the wiring, and we're going to bury the wiring parallel to the roadbed along the tracks. We need to solder the wires to the pickup tracks, and to do that we're going to cut the red and black wire at different lengths so that they don't short each other out. Now the wire that we're using here from the pickup tracks is 18 gauge. The wire that we're using for the bus wire all the way around the layout is 12 gauge. And the wire that comes from the pickup tracks is just a short section, so being smaller is not going to cause any problem. We're going to twist those wires together and then give them a good coat of solder. Now you'll notice that we're not going to use any protection over these solder joints. This is just low voltage current, so they can be buried right in the dirt. It's not necessary to cover them up. It's important to get a good solder joint, and this will be made easier if you tin the ends of your wires first. This bus wire is really going to help carry current all the way around the layout so that we don't have a loss in current or loss in resistance during the time the train goes around the length of the track. After you get the wires soldered, then we want to staple the wires to the side of the roadbed so that they're hidden out of sight. We're going to ballast over the top of these later on. You won't see the wires at all. We staple them in place. Stainless steel staples would be a good idea so they don't rust. You want to keep these wires nice and snug against the side of the roadbed so they don't get damaged during planting or other maintenance later on. Now once we've completed the wiring, we can go ahead and fill back over the wires again. We're going to ballast right over the top of all this so the wires won't be seen at all.
Now we need to talk about insulated joiners, passing tracks, and switches. If this is the first layout that you've built, this example will help to demonstrate the various components of our electrical system. The switch controller is a momentary spring-loaded switch that throws our turnout left and right. The block control controls power to the various sections of our track, which are divided by insulated joiners shown by the arrows here. The insulated joiners have a divider that prevents the flow of electrical current across the joint. Once inserted on the rail, it prevents the ends of the rail from touching. We're going to insulate both rails of our track because we're going to use our railroad as both a conventional and a digital railroad. Here you can see that it prevents that current from flowing across this joint once it's put together. The transformer provides variable DC current for our block control. Block control controls 4 separate blocks. Switch A allows current to flow out to block A through our power feed track on that block. Switch B allows current to flow to block B on our other passing track. Switch C allows current to flow out to block C, which is our main line. The transformer also provides low voltage AC current through the accessory side of our transformer to the switch controller. Power then flows through one of the 4 switches out to our switch motor on the turnout. Assume we have 2 trains coming down the main line. The first train enters block A. We turn off block A, throw the switch to the other passing track. The second train comes along and passes on the passing track. Let's talk about options for train control. There's many types of transformers and equipment out there, and it's best to check with your manufacturer about what they recommend. In our example, we used a handheld walk-around control and an MRC ControlMaster 20 transformer. This transformer has filtered DC power. You wouldn't, however, want to use this out in the rain. We have 2 options that we're going to use on our railroad. The first is LGB's outdoor train control. This is really a great control for kids outdoors. There's no high voltage current and nobody can really get hurt out in the weather. The second option is the walk-around control system from Aristocraft. It has a 10 amp receiver, which is really good for the large trains for outdoors. There's a handheld walk-around control that makes it very convenient to be able to follow your trains. Space age technology brings us digital train control. This greatly simplifies the need for electrical wiring and opens up a whole new way of realistic train control. Unless you're using stainless steel track, there's an important electrical consideration you need to know. You have 4 options. You can solder a wire around the rail joint on the outside of the rail, or you can drill 2 small holes, one on either side of the joint, slide a piece of wire through, and then solder them from the inside. You can use rail clamps over the top of the rail joiners and fasten them down securely, or you can use a rail clamp that's on the bare rail itself. But whatever you do, you need to ensure this continuity across the joints. Let's ballast some track. The ballast we're going to use is a crushed granite. It comes in different sizes, but the size we're going to use is what they call fines, or it's smaller than 1/4 of an inch in diameter. Usually it's what's left over from the screenings when they grade the different sizes of ballast. We made a piece of wood and cut some slots in the board to be the same width as the rails so that we can help work the ballast down between the ties. We're going to work it back and forth several times here to kind of get it worked in. Then we're going to use the side of the board to kind of shape the side of the ballast so that it gives a little bit of an angle along the side of the track.
Once we do some shaping, then we're going to run the board back over the ties again and work it down some more. Now at this point you could probably switch to a brush, and we want to brush some of the loose material out from between the rails, shaping as we go on both sides. I might add that it's important that you use a crushed rock like crushed granite, because if you use a gravel which has a round surface to it, it'll tend to wash away in the rain. The irregular shape of the granite, the crushed granite, tends to hold its shape. Now we've completed this pretty much. We're just making some finishing touches here, and then we're going to wash it down with water to work in the dust off the ballast and make it look a little bit more natural. You want to do this with a light spray. You don't want anything too strong or you'll dislodge the ballast from where it's between the rails. As we do this, you'll notice that the ballast is going to change color. What's happening is we're washing all of that dust away. It looks a lot more natural. It'll look even better after it dries. Now we're going to add some mulch. Mulch really does two things. It helps to give us a border, and it also helps to hold the moisture around the plants. Before we finish the rest of our mulching, I think we're going to add a few landscape rocks. This little rock weighs more than 800 pounds, and although you may not want to put something in your garden this big, we decided that it'd look good right in this spot. After you get it in place, you want to get it seated pretty good. We wash the soil in here. Doesn't it look pretty good? Nothing adds a more relaxing atmosphere to your garden railroad than the sound of falling water. You'll need to have a fountain in your pond if you plan on having fish. The fountain aerates the water and allows the fish to breathe. The waterfall is not going to supply enough oxygen for that purpose. Fish also perform another function, and that is to remove algae from the pond. There are so many different kinds of ponds and waterfalls. It's really important you get advice from your local supplier as to the type of pump that's required to bring the water to the top of your waterfall. Also, the depth of the water is important for the fish. They need a place to get in out of the sun when the weather gets hot. We've put our pump into a 5-gallon bucket with a piece of screen wire on top to keep out the leaves. Underneath the screen wire, there's a rubber foam filter, and the pump is at the bottom of the bucket. That helps to keep debris out. We have two different kinds of pond liners in our pond. One is a preformed pond at the top of the waterfall, and the other one is a rubber pond liner, which we used in the big pond. You pull that up around the edge, and then you can keep it in place by placing rocks on top of it, like you see here. We've exposed some of the liner so you can see what it looks like underneath. We just pull it up maybe a foot or so past the edge of the pond and cover it up. A pond really offers you the opportunity of having two gardens in one, a water garden and a garden railroad. It's really a lot of fun. Get the whole family involved. You'll really enjoy it. Let's go inside for a minute and build a stone bridge out of styrofoam. We're going to use a hot wire pen to cut our mortar lines in the styrofoam, and then we're going to texture the styrofoam with a wire brush. Make sure you have good ventilation while you do this because the fumes are toxic. After we texture the styrofoam, then we're going to use black paint and paint the entire surface. We're going to let the black paint dry a little bit, and then we're going to use a little bit of white paint, and we're going to dry brush some of the highlights over the top of this. This is pretty easy and it's a lot of fun. Styrofoam holds up real well outdoors as well. We do want to protect the top edge of the styrofoam, however, with something more solid like wood. That way if somebody steps on it, it won't damage it. Once this is all put together, it really works pretty well. Looks good too. The cog railway uses a special rack locomotive with a cogwheel underneath. The cogwheel meshes with a separate rack rail that allows it to climb a maximum 25% grade. Plus Replace a rack rail holder every 4th or 5th tie. This unusual locomotive will add a lot of interest to your layout. Our trains go behind the wall, which gives the illusion of having long tunnels. It's important to have access to your tunnel for track maintenance or to clear up an occasional derailment.
Whether you build a small, circular layout or a large, spectacular layout like the one here at Cypress Gardens, it won't be long till you'll be able to say, look what's growing in the garden.